Hi, everybody. Welcome back to the lecture series on statistics. Today, we're going to talk about one of two forms of descriptive statistics. Now, you may recall that statistics, we have descriptive statistics, which are designed to summarize scores, whereas inferential statistics were meant to draw interpretations about a population from a sample or draw meaningful conclusions about our statistical analyses, whatever it might be. Now, within descriptive statistics, we have measures of central tendency and measures of variability. Today, I'm going to focus on measures of central tendency, and the three measures of central tendency you probably have already heard of being the mean or average, median or 50th percentile, and mode, the most frequently occurring score. So this should be a relatively short video, but I'm going to show you how to calculate each of these processes by hand and come to a meaningful understanding. All right, so let's imagine that we had a researcher who is interested in measuring motivation. And scores ranged from very low motivation or 1 to very high motivation or 7 on a measure. Now, here what I've presented is a frequency distribution or a set of scores, better yet, I'm going to turn it into a frequency distribution with 11 participants. So we had one person say 1, one person say 2, 2 people say 3, 3 people say 4, 2 people say 5, one person say 6, and one person say 7, right? So this could be a frequency distribution. Now, if I wanted to calculate the average, the median, and the mode, I would have to transform these scores, right? So X at the top is a score, and then you see sum, which is to add up. We added up all the scores and we got 44. So the calculation for mean is the sum of X divided by N, or the sum of the frequency of X divided by N. And I'm going to show you how to calculate the mean with both of them just pretty shortly. Now, if you want to understand the mean does not show you magnitude, like peaks in the distribution. Rather, it shows you the location, and it gives you the center of a distribution. That's what the mean is doing. It's one of the ways of measuring central tendency. So if we were to just add up all the scores, that would be insufficient for our calculation purposes, right? So we have to add up all the scores and divide it by N, N referring to the number of participants in our study. Now, you will see some textbooks write the Greek symbol mu, and some textbooks will write X bar, or X with the line on top of it. But in general, that means something. Remember that we use Greek symbols when we're working with a population, and standard English characters when we're working with a sample. So, in general, going back to an earlier lesson about the basic rules, I said there are 8 rules, right? That we could extrapolate from PEMDAS. So go to the first lecture if you're interested in my introduction to statistics. But here's the application of the rules to the mean. So if you add or subtract from every score in the distribution, the average would be increased or decreased by that constant. You can see that was reflected in Rule 6 and Rule 7 from the first lecture. Additionally, If you multiply or divide by a constant, the average or mean will be multiplied or divided by that constant, similar to that which we said in Rule 8. So now, another thing is that, and this is going to be crucial for the next lesson I give on measures of variability. If we were to subtract the average from each individual score, the sum of all differences or deviations from the average would always equal 0. Now, I'm planting a seed. This isn't necessarily important for this lecture, but when we learn about variance and standard deviation, it's going to be much more important. So the sum of deviations is always equal to 0. Sum of deviations is x minus x bar. Now, sum of square deviations is going to give us some sense of variability from a center point. Now, before I go into the median, I'm going to show you how to calculate the average. And I gave you 2 different formulas. So what I'm going to do is I'm going to show you how to do it in a standard sum of x divided by n. And then I'm going to show you how to do it with the sum of the frequency of x divided by n. And I'm going to use the data set that I presented for motivation for this demonstration. So let me get to set up on the whiteboard, and then we will continue. All right, so here we are. What I did was I just wrote the same data set that we saw earlier on the slide deck onto the whiteboard. So I wrote X representing a single score, right? And then here are the individual scores on motivation. So how many participants do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 participants. So this is going to be crucial. What I'm going to do here is I'm going to write, if the marker works, well, I'm going to write n equals 11. And we're going to come back with a better marker. All right. So what I'm going to do is I'm going to write the symbols again, and I'm going to make them in blue so it's easier to see. So we have our sigma, and I asked us to count the number of participants in this data set, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 participants in the data set. And now I'm going to add up this column, right? So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 4 is 13, 13 plus 4 is 17, 17 plus 4 is 21, 26, 31, 37, 44. Great. So I wrote the sum of the column is 44 and n is 11. So our formula for mean is x bar is equal to, can you see that? Yeah. X bar is equal to the sum of x over n. Well, what is the sum of the x column? The sum of the x column is 44. And how many participants do we have? The n is 11. So 44 divided by 11 would give me a mean of 4. So that's my mean, right? So I should be able to do x bar is equal to the sum of x over n. The sum of x was 44. The number of participants, or n, was 11. 44 divided by 11 gave me a mean of 4. Now, I want to show you that there's another formula, or the sum of fx divided by n. So that other formula for mean, I'm going to have to calculate another process. So I'm going to have to do this x column again. All right, so I have my x column, and now I'm going to do 1, 2, 3, 4, 5, 6, 7. So I have all the same numbers I had here, but now I'm going to create a frequency column, an F column. How many times did 1 happen in a distribution? Once, right? How many times did 2 happen? Once. How many times did 3 happen? Twice. How many times did 4 happen? 1, 2, 3. 3 times. How many times did 5 happen? 1, 2. 2 times. How many times did 6 happen? Once. And how many times did 7 happen? Once. Now, remember how I said the total number of participants is 11? The sum of the frequencies is your total number of participants. So when I add this column up, I should get 11. So 1 plus 1 is 2, plus 2 is 4, plus 3 is 7, plus 2 is 9, plus 1 is 10, plus 1 is 11. Great. So now I know that the numbers I put up here in the F column are the same as the original distribution. Now, the other formula for mean is the sum of fx, right? Sum of fx over n. So that's your mean. So I need to do an fx column. Now, when we have 2 letters that are next to one another, when you have 2 letters that are next to one another, you multiply. So I need to multiply this number by this number. So 1 times 1 is 1. 2 times 1 is 2. 3 times 2 is 6. 4 times 3 is 12. 5 times 2 is 10. 6 times 1 is 6. And 7 times 1 is 7. Now I'm going to add that up. If the sum of fx is like the original distribution, I should get 44 because that's what I got here, right? So 1 plus 2 is 3, plus 6 is 9, plus 12 is 21, plus 10 is 31, plus 6 is 37, plus 7 is 44. Okay. So now we have something interesting, right? So what was the sum of the fx column? Go to the bottom that we added it up, 44. And then we divide it by n, the number of participants, which was 11. So once again, 44 divided by 11 gives us 4. So when we're doing the mean, you can do the traditional sum of x divided by n, add up all the individual scores, divided by the total number of participants, or you can do an fx column and calculate it. Both you should get the same distribution. Now, another thing that's really interesting about the fx column, though, is I said we want to know the most frequently occurring score for the mode. You can see in the F column, F stands for frequency, right? You could see in the F column which one is the most frequently occurring, which we'll get back to right here later in the video. That's going to be easy. So we have already set the stage for talking about the mode. Now I'm going to go back to the slide deck and come back for the median. I'm going to explain the median. I'm going to teach you the formula, how to calculate the median, and then we'll move on. So let me pull up the slides for us and we will continue. All right, so we're back looking at the median. The median, as we learned in the previous lesson, was the 50th percentile. So if you go to the lesson on calculating raw scores, when a percentile is given, the way to calculate the median by hand would be the same formula that we learned in the previous lesson. So if we were to look at the formula, this should look familiar, right? So the score in question, right, is score P, or score 0.5, is equal to the lower real limit plus P times N minus the sum of the frequencies below, divided by F times H, or the height. And we're going to do that formula shortly, but let me teach you some of the additional properties. In general, if you have a symmetrical distribution, the mean, median, and mode should be equal. I talked to you, though, that it's possible to have a skewed distribution. Remember, the average, the mean, is shifted as a function of extreme scores, right? So if you have a positively skewed distribution, the average is going to be brought up by a few really large scores. If you have a negatively skewed distribution, the average is going to be brought down by a few extreme scores. Now, to give you something to think about, if I were to ask you for an individual person's income, what do you think the average income is? Well, you might be shocked to hear that the average income is about $70,000. But if I were to ask the average person on the street what they make, many people, more than 50% of people, actually don't make $70,000. So if I were to ask for the median, it would be more representative because it's not offset by real extreme scores. So when we talk about billionaires, they're bringing the average income up versus the median, where we just put you in a rank order. So the point I'm trying to make is the median is uninfluenced by extreme scores, whereas the mean is sensitive to extreme scores. So let me go back to the board, and I'm going to set up the formula, and I am going to erase the individual column. And what I'm going to do is I'm going to keep the X and the F column there, and we're going to work off of that to calculate our median. So give me a chance to set up, and I'll be right back with you. All right, so what I've set up over here is the same X column and the F column that we had for the mean. And then I wrote the median formula out, which is lower real limit plus P times N minus the sum of the frequencies below, divided by F times H. Now, if the formula is hard to see, that's okay, because I put it on the slideshow as well. So the first thing I'm going to do with my X column and my F column is I actually think we should make a CF column. So let's make a CF column. Now, you may remember from lecture 2, where we talked about frequencies and frequency distributions. When we're calculating the cumulative frequency, we actually start from the bottom and work our way up. So bring the 1 over. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 1 is 10. 10 plus 1 is 11. So my cumulative frequency column works out that the sum of F, which was 11, is equal to the top of the CF column. So I know I did that right. All right, so step one, I need to figure out my 50th percentile, right? Which is P times N. We do 0.50 times N. Well, N was 11. What's 0.5 times 11? Well, that's 5.5. So the first thing I'm going to do is see if I can find where case 5 would be. So as I work up, well, this has case 1, this has case 2, this has case 3 and 4, this has case 5, 6, 7, and we work our way. So what I'm going to do is I'm going to say, this is my number right here. So I found my class interval. Now, interesting to note, in this case, we don't have a grouped frequency, so the class interval is just one number. So my class interval is going to be 4. And then the lower real limit, remember the lower real limit, we take whatever the number is, and we subtract 0.5 from it. So 4 minus 0.5 is 3.5. And now I think we're ready to plug in our formula. So I'm going to take this lower real limit and I'm going to do, what's lower real limit? 3.5 plus, I'm going to take P times N, which was 5.5 minus the sum of the frequencies below. So what is the sum of the frequencies below? 4, right? If this is 7, I go to my cumulative frequency table and I find 4. So we go 5.5 minus 4 divided by F. So I go in here and I see my F here is 3. So the frequencies there is 3 times the height. Well, the height is going to be 1 because we only have one score here. So now I have all my numbers. So I'm going to lower the camera so you could see. 3.5 plus 1.5 over 3 times 1, right? So we are going to do 3.5 plus 0.5, which gives me 4. That's my median. That, my friends, is all she wrote, right? So I use the same formula of calculating a raw score when a percentile rank is known. Median is 50th percentile, and I work my way through it. So if we're keeping score, the mean was 4, the median was 4. And if we can go up and identify the most frequently occurring case, right? So class interval, I go in the F column. This is 3, go to the X. The mode is also 4. So 4 occurred 3 times. So in this particular demonstration, the mean, the median, and the mode were all equivalent. Now, think about what I said earlier in the lesson. I said that if you have a symmetrical distribution, the mean, median, mode would be symmetrical, or would be the same, forgive me. So we have no skew in this distribution, which is pretty cool. So I'm going to go back into the slideshow, finish this up, and we should be ready to hit the road shortly. All right, so this is the last slide. As I said, the mode is the most frequently occurring score. In the demo that I did earlier, the mean, median, and mode were identical, meaning that it was symmetrical. Now, here's an interesting thing about the mode. Unlike the median, where you're going to have one number to reflect it, and unlike the mean, where you're going to have one number to reflect it, it is possible to have 2 or more modes, right? So you can have a bimodal distribution. That's just a fancy way of saying you have 2 modes. So it's possible to have two peaks in your distribution, or sometimes even three peaks, but that is what we look for. If we had a symmetrical distribution, we should have one peak, typically, right? If it's normally distributed, I should say. If you have two modes, two peaks, you probably are reflecting two different groups within your sample. Something to think about. Other things to say about the mode is the least sensitive of the three measures of central tendency. So it misses a lot. It misses a lot of what's going on in the data. But when you have nominal or categorical data, the mode is the measure of central tendency you would report, whereas the median would be reported in ordinal data and the mean would be reported in interval and ratio data. So that is, in a nutshell, today's lesson. I'm going to do another lesson on measures of variability. And instead of looking at how scores come together at a center point, as we talked about today, now we're going to start looking at the spread of scores. So that will happen in the next lesson. Well, take care for now and happy studying to all.